Hello everyone, my name is Jun Wang from the College of Resource and Environment, Shandong Agricultural University. First of all, many thanks to Science Father for organizing the award event. I'm entered for the award for Best Research Scholar in Environmental Science. My presentation is titled Soil Pollution Risk and Control. I will begin my report in three ways. Firstly, main scientific questions. Secondly, main research results and innovations. Thirdly, research impact. First, scientific question 1. The detection of pollutions often requires large and expensive instruments, complicated operation, and difficult to achieve real-time monitoring on site. In addition, pollution effects are difficult to diagnose early. More and more pollutions, such as antibiotics, heavy metals, and pesticides, enter the soil environment. This will lead to physiological and biochemical damage to plants. But how to detect this pollution effect earlier and more sensitive is important. So, how to achieve highly sensitive detection of pollutions and accurate identification of pollution effects? The second key scientific issue is that pollutions are complex and diverse, and their ecological effects and molecular mechanisms are unknown. For example, ectoxic effects on plants, soil fungal, soil microbes, fish, and algae. What are the ectoxic effects and molecular mechanisms of pollution? After understanding the toxicity and the risk of pollution, how to build a system of pollution abatement and containment is the third key scientific question. Some of the remediation methods include battle remediation, animal remediation, microbial remediation, and materials remediation. Based on the above three key scientific issues, we have carried out a series of work on the detection and identification of soil pollution, risk assessment and control, and remediation. Highly sensitive detection of topical pollutions and precise identifications of pollution effects have been realized. The ecotoxicology effects and molecular maintenance of topical pollution have been reviewed. Soil pollution remediation and control technologies have been developed. The research result provides stronger theoretical and methodological support for realizing the scientific objectives of early warning, risk assessment, and precise control of topical soil pollution risk. In terms of main research results and innovations, it relies highly sensitive detection of pollutions and accurate identifications of pollution effects. In terms of key findings, to expound on this, in response to scientific question 1, we have constructed a series of new novel biosensors to achieve specific recognition of topical pollutions and improve detection sensitivities. For example, a senior standards DNA bonding protein and DNA functionalized guard nanoparticles. Herbert triggered ssDNA adstrobed on nanosheets and asthmatics signal application. Our detection limits for the antibiotics maclin and canamical are above 10 to the minus 12 power of milliliter per liter. And we also created a senior for some heavy metals ions. Second, we have solved the challenges of specific and highly sensitive detect of epigenetic modification molecular, including 5-MC, 5-HMC, microRNAs, and realized the early identification of contamination effects at the gene level. The innovations combination of covalent recognition, immune recognition, and photoelectrical chemical sensing slowing the difficulty of a carrier detection of epigenetic modified molecular in corrupt tissues. In response to scientific question 2, we integrated traditional toxicology indicators at multiple levels and multi-omics techniques to review the ecotoxicology effects and molecular maintenance of topical pollutions such as pesticides, flax, and heavy metal, and on soil animal such as earthworm, plants such as wind, rats, and microorganisms such as bacteria. Second, using photoelectrical and chemical techniques, we propose to induce epigenetic molecular into the evolution of ecotoxicology effects in groups. We found that low dose of heavy metal ions can induce abnormal expression of epigenetic molecular in group settings and developed new and more sensitive biomarkers. For example, heavy metals, mercury ions, chlamydia ions inhibited 5-HMC expression in genomic DNA of rat-siding levels. SDZ, chlamydia ions promise 5-FC expression in genomic DNA of white levels. In response to scientific question 3, we scanned topical pesticides endosulfan and artisan, as well as the antibiotic SDZ for ancient degrading bacteria, and the degradation pathway and the maintenance of the pollution were explored. For field application, they developed implantation technology greatly improved the stability and application range of bacterial enzyme preparations. Secondly, from the point of view of local materials and pollution control, by this, we have prepared a series of modified biochar loading materials based on food waste, corn stalk, penny shells, and other waste as raw materials, which have realized effects abatement and blocking and control of topical heavy metals. Based on scientific and technological innovation, a number of original scientific research results have been achieved. We have published nearly 50 papers in the last 5 years, published in Applied in Catalyst B, Environment and Energy, Environment International, Chemical Engineering Journal, and the Science of the Total Environment. The representative achievements in pollution research, risk assessment, and toxicology was published as sister paper in the Journal of Hazardous Materials. These papers have garnered attention and coverage from media platforms such as Environmental Advance, ScienceNet, and China Science Daily. The significant achievements in pollution reduction and control were published in the top-tier environmental journal Applied Catalyst B, Environment and Energy. These findings have been vividly covered by over 12 media outlets, leading to significant impact and resignation. Lastly, I would like to thank Science Father again for giving me the opportunity to apply for this award, and I will continue to work hard. Thank you very much.